Hello everyone, welcome back to RC Circuits. This is lecture number 7. So in previous lecture we have discussed uh, some concepts like when there is an impulse current flowing through the capacitor, then how does the capacitor behave? So when an impulse current is flowing through the capacitor, then there is a sudden change of voltage across the capacitor. So in general we have seen that the capacitor voltage does not allow the sudden change, right? So but when there is an impulse current, let's say, when there is very infinite current or impulse current flowing through the capacitor, then there is a sudden change of voltage across the capacitor. And also when there is a constant current flowing through the capacitor, let's say if you pump some constant current through a capacitor, then the capacitor voltage will change linearly. It means that the capacitor will charge linearly. So these two concepts we have seen, and we will discuss some problems in this lecture. So in the given circuit there is one voltage source, and at t is equal to 0 the switch is closed, and we have two series capacitors. So suppose if you want to find time constant of the circuit, then you have to short circuit the voltage source, right? So for t greater than 0, so for time constant you have to check for t greater than 0. So for t greater than 0, how the circuit will behave? If you want to find the time constant, then short circuit the voltage source, then you have two capacitors are in series. So this is nothing but C1 C2 are in series, right? It means you will get equivalent capacitance as C1 C2 by C1 plus C2, and in series with a 0 ohm resistor. So this is shorted, right? So if you see across the capacitor terminals, then you have 0 ohms. So this is 0 ohms. So you will get time constant as 0. It means there is a sudden change of voltage in the capacitor. So if the time constant is 0, it means sudden change of voltage. This is one way of saying. So let's say at t is equal to 0 plus. What do we do at t is equal to 0 plus? We generally, since the initial voltage across the capacitors are 0, assume, then at t is equal to 0 plus we have to short circuit the capacitor. So you have Vs and short circuit C1 and then short circuit C2. It means you are directly applying the voltage source through a 0 ohm resistor ideally. So which means an infinite current is flowing through the capacitor. Then if impulse current is flowing through the capacitor, then there will be sudden change of voltage. So this we can represent as, so from this we can say sudden change of voltage. Sudden change of VC, voltage across the capacitor. So if you want to find voltage across the capacitor, then since at t is equal to 0 plus, the capacitor, it is seeing very high frequency, right? So at very high frequency the capacitor will behave as a very low impedance. So I can represent those two capacitors as the same but with very low impedance. So we have C1 and C2 and Vs. So these are very low impedances. So at t is equal to 0, now you have C1 and C2, right? So if you find VC1, then it is Vs times opposite capacitor by total capacitance, which is C2 by C1 plus C2. And similarly, Vc2 is Vs times C1 by C1 plus C2. So you have initially 0 volt, but now the capacitor voltage is becoming this much. So it means there is some sudden change at t is equal to 0. That is what is happening. Now at t tends to infinity, which is at steady state. So at t tends to infinity, assume it is completely charged. It means the capacitor will be open circuited, right? So you have one voltage source and open circuit the capacitors. It means you have a very high impedance of the capacitors. So C2, C1, these two are acting as very high impedances since the frequency is 0 at steady state. So Vs, now if you find Vc1, then Vs times C2 by C1 plus C2, and Vc2 is Vs times C1 by C1 plus C2. So if you see the voltage Vc1 and Vc2 at t is equal to 0 plus and at t tends to infinity, then these two are same, right? So Vc1 and Vc1 at t is equal to 0 plus and t tends to infinity are same, and same as Vc2 also. It means there is some sudden change of behavior across the capacitor voltage and it is remaining constant till t tends to infinity. It is not changing. So that is how we will solve this type of circuits. So if you draw Vc1 with respect to time, initially it was 0. Now at t is equal to 0, it is changed to some voltage and it is staying at the same voltage till t tends to infinity. So this is Vs times C2 by C1 plus C2. And similarly, if you find Vc2, then initially it was 0 and at t is equal to 0, it is changed to some other voltage, which is Vs times C1 by C1 plus C2, and it is staying at the same voltage till t tends to infinity at steady state. So this is what is happening. And if you want to find the current flowing through the capacitor, since both are in series, the same current is flowing through both the capacitors. So if you find IC1, so from the equation, the relation between the capacitor voltage and the capacitor current is I is equal to C dV by dt, right? So it is C dVc1 by dt, which is C1 dC1 by dt. So if you find that, then you will get, before that we can write the expression for Vc1, right? Then we can derive that. So Vc1 is, it is 0 for t less than 0 and it is this value for t greater than 0, which is, this is a unit, not unit, it is a step function with this amplitude. So we can write it as Vs times C2 by C1 plus C2 times u of t, and Vc2 is similarly Vs times C1 by C1 plus C2 times u of t. So then you can find the current also, which is C1 times dVc1 by dt. If you differentiate this one, the differentiation of u of t is impulse function, which is del of t, and this amplitude remains same, which is constant. So Vs times C2 by C1 plus C2 times del of t. So you will get IC1 is equal to IC1 of t is Vs times C1 C2 by C1 plus C2 times del of t, which is an impulse function with this magnitude. This magnitude represents the area, right? So that is how it works. And if similarly, if you find IC2, you have to get IC1 is equal to IC2. Let's check that. So Vs times, which is C2 times dVc2 by dt. So C2 times, if you differentiate this one, then this constant Vs into C1 by C1 plus C2 times del of t. So IC2 is Vs times C1 C2 by C1 plus C2 times del of t. So you can say IC1 is equal to IC2. So that is what from the circuit also, since both are in series. So if you draw the waveform of the current, so IC1 is equal to IC2 is equal to source current. So this is also source current. So I can draw directly source current, which is an impulse function. So the impulse function can be represented with this symbol. So just an arrow, and you have to write the amplitude here, which is Vs times C1 C2 by C1 plus C2. So yeah, you no need to derive these equations also. So from this graph, the current through the capacitor is C into dV by dt, right? So which means you have to derivate this waveform. So here it is constant, which is 0. So you will get the current as 0. And also here also it is constant. So if you differentiate the constant, you will get 0. So for t greater than 0 also it is 0. But at t is equal to 0, there is some change in the voltage, right? From 0 to this value. So if you write C1 into this delta, which is Vs into C2 by C1 plus C2. So C1 into Vs times C2 by C1 plus C2. So that is nothing but this magnitude. So directly if you differentiate this waveform and multiply with C1, then you will get this waveform, which is impulse function. So that is how this circuit works. Yeah, and I think you have understood this one. So let's move on to next circuit. So here the circuit is given and the 5 volt is applying at t greater than 0. So if you find the time constant of the circuit for t greater than 0, then you have to short circuit the voltage source, right? So just short circuit that, and you have this resistor, this capacitor, and this capacitor. So this is one terminal of the capacitor C2 and this is one more terminal, and across the same terminals the capacitor C1 is also connected. So this terminal is connected to this terminal and other terminal of C1 is also connected to this terminal of C2. It means C1 and C2 are in parallel. So if you look at this circuit, then it looks like this one, and the resistor R is also in parallel with the both the capacitors. So it looks like this one. You have resistor R and two capacitors are in parallel, which means you will get C1 plus C2. So since you have only one capacitor, this is a first order circuit. So which implies this is a first order circuit. So if you find the time constant, then C1 plus C2 times R. So we have some time constant. It means the capacitor is taking 5 times of time constant to reach to steady state. Let's check that. So it should have reached to steady state exponentially. So from this time constant, so we are assuming like that. So let's say the capacitor is at some voltage and steady state is at some other voltage. So it will reach to the steady state after 5 time constants. Let's check that. So now at t is equal to 0 plus, you have to short circuit the capacitors because the initial voltage is 0. Then you have this circuit, short circuit C1, then short circuit C2. So this is short circuit and this is short circuit, and you are applying 5 volt. So since the resistor is in parallel with the short circuit, you can ignore this resistor, right? So you remove this resistor and you have only short circuit path in parallel to a voltage source. It means there is infinite current will flow through the circuit, through the both the capacitors actually. So which means there will be sudden change in the voltage across the capacitors. So since if you want to find the voltage across the capacitor, then this is 5 volt, and then you have short circuit, which means it is very low impedance. So if you have a very low impedance in parallel to any other impedance, then effectively it is equivalent to near to the very low impedance. So that we have already discussed. So you can directly write with a capacitor and you can ignore the resistor, and this is C2. So these two are low impedances. So VC1 is 5 times C2 by C1 plus C2, and VC2 is 5 times C1 by C1 plus C2. So if you, that is at t is equal to 0 plus, and for t tends to infinity, you have to open circuit the capacitors, assuming it is fully charged. So you have resistor, and in parallel you have a capacitor which is open circuit at t tends to infinity, and you have one more open circuit capacitor. So this is C1 and this is C2. So this is VC2 at t tends to infinity, and this is VC1. So since it is open circuited, there is zero current flowing through the circuit, right? So this is 5 volt. So you have zero current here. If there is some 0 amps of current is flowing through a finite resistor, so this is finite resistor, then you have voltage drop of 0 volt, right? So you have 0 volt of voltage drop. So this 0 volt is in parallel with the capacitor C1, right? So VC1 is 0, and see here you have 5 volt across these two terminals, and you have 0 volt from here to here. So you will get, if you apply KVL here, so it is 5 volt and 0 volt, and you have VC2. So if you apply KVL, then you will get this 5 volt directly across the capacitor C2, right? So VC1 is 0 and VC2 is 5 volt. So this complete 5 volt will appear across the capacitor C2. So these are the steady state voltages of both the capacitors. So if you draw the waveforms, So let's say this is for Vc1 with respect to time. Till t is equal to 0, it is 0. And at t is equal to 0, the voltage across the capacitor C1 is going to 5 times of C2 by C1 plus C2. So for simplicity, let's assume C1 is equal to C2, which means this is going to 2.5 volt, and the same as for C2, this is 2.5 volt. So it will go to 2.5 volt, and at steady state Vc1 is 0, so it will go to 2.5, then it will start exponentially, it will go to 0. So this is how it behaves. And what about Vc2? So Vc2 with respect to time is, till t is equal to 0, it is 0, and then at t is equal to 0, it is going to 2.5 volt, and at steady state Vc2 is reaching to 5 volt, right? So it will reach to 5 volt exponentially, and it will stay at 5 volt. So this is how it behaves. This is 5 volt. So if you can directly draw IC1, IC2 also. Yeah, if you draw IC1, then see, IC1 is C times dV by dt, right? So for t less than 0, Vc1 is 0, so IC1 is also 0. But at t is equal to 0, Vc1 is changing abnormally. It is changing suddenly from 0 to 2.5. So which means there is impulse current is flowing through the capacitor. So at t is equal to 0, I can represent with an impulse current with the magnitude of C1 times dV by dt, right? So which is nothing but C1 times, so this change is 2.5, so it is 2.5 C1. And also the voltage across the capacitor C1 is discharging exponentially. So if you remember, if a capacitor, we generally represent the current in this direction, right? If there is some voltage, but this voltage is discharging, I mean this voltage is decreasing exponentially. It means the capacitor starts discharging, right? It means there should be the current flow in this direction. The current should come out of the capacitor, then only the voltage across the capacitor will decrease. Or in other words, we can say there should be the current flow across the capacitor in this direction, so that this voltage will decrease and then it will decrease to 0. So from this direction we can say the current IC1 through the capacitor is negative because it is discharging. So that is some logic. So it should be in negative in magnitude. So IC1 is negative, and we don't know this voltage, we can, I mean this current, so we can find it later. So at t is equal to 0, there is some impulse current, and immediately it will go to some negative current at t is equal to 0, and then for t tends to infinity, the voltage is 0, since so that the current will also go to 0. So this is happening for capacitor C1. And what about C2? So current through C2 is IC2 with respect to time t is till t is equal to 0, the voltage is 0 and current is 0. And at t is equal to 0, there is some sudden change, right, for C2 from 0 to 2.5. So there should be an impulse current. So there will be an impulse current with magnitude of C2 times this voltage, this change in voltage. So this change in voltage is positive, so you have a positive impulse. So the change is 2.5 times the capacitor C2, and the voltage is charging exponentially, which means there should be current flowing through the capacitor in this direction, so which is positive. And for t tends to infinity, the voltage is constant, which means it is completely charged, it is at steady state, so you will get the current as 0. So at starting there will be high current. So for C2 at starting there will be high current because it is at 2.5, and when it starts charging up, the voltage will increase, which means the current will be reduced and it will go to 0 at steady state. So you have some voltage at t is equal to 0, and this will go to 0 for t tends to infinity. So this is the current flowing through the capacitor C2. Now the only thing remaining is you have to find this amplitude and this amplitude, right? For that you need the exact equations of Vc1 and Vc2. So let's find that. So Vc1 is initial voltage is 2.5 and finally it is going to 0. So it should be 2.5 times e power minus t by tau. So e power minus t by, what is the time constant we have found, right? So the time constant is C1 plus C2 times R. C1 plus C2 into R. So U of t. Since it is only for t greater than 0. So this is Vc1. And what is Vc2? Vc2 is final value is 5 volt. So final value plus initial value minus final value times e power minus t by tau. C1 plus C2 times R. So which is 5 minus 2.5 e power minus t by tau. And this is 2.5 e power minus t by tau u of t, and this is also for only t greater than 0, so times u of t. Yeah, so for current IC1 is equal to C times dV by dt, right? So if you don't know the graph, this graphical method, then you can also write in this form: IC1 is equal to C1 times dVc1 by dt. So you have like two functions in time, which is e power minus t by tau and u of t. So first differentiate one keeping other one as same, and differentiate other one keeping the remaining one as same. So that is how you differentiate a function with two different let's say f1 of t into f2 of t, like that. So IC1 is C1 times, so if you have two different time varying functions, then you have to write 2.5 times, first keep this as same and differentiate u of t, you will get del of t, and plus 2.5 times keep u of t as same and differentiate this one, which is minus 1 by tau e power minus t by tau. So IC1 is equal to C1 times. So if you multiply del of t with any other function, you just have to substitute t is equal to 0 in this function. So you will get 1. So this is 2.5 del of t plus minus 2.5 by tau e power minus t by tau u of t. So this is the expression for this waveform IC1. So you can check here. So we have impulse function, right, which is 2.5 times C1 times del of t. So the magnitude is 2.5 C1. And you have some exponential function which is in negative amplitude, which is minus 2.5 by t C1. So that is this magnitude minus 2.5 C1 by tau e power minus t by tau. So for t tends to infinity, it will go to 0. So that is about IC1. And for IC2, you can find this similar way. So we can derive that IC2 is equal to C2 times dVC2 by dt. So C2 times, this is constant. So I'm saying first keep this as same, then differentiate u of t, you will get del of t. Then keep this as same, then differentiate this inside function, you will get 2.5 by tau e power minus t by tau. So the C2 is multiplied with whole the function. So C2 times, if you substitute t is equal to 0 in this expression, you will get 5 minus 2.5 plus 2.5 by tau e power minus t by tau u of t. So I forgot del of t, so this is del of t. So you will get 2.5 C2 times del of t plus 2.5 C2 by tau e power minus t by tau u of t. So you have an impulse function at t is equal to 0, which is 2.5 times C2 in magnitude. So that is what we have already got. And this magnitude is 2.5 C2 by the time constant tau. So this is how you can find the expressions also. And if you don't want to find the expressions, and with intuitively if you want to draw, this is how you can draw the voltage and current through the capacitors. Yeah, so this is about this circuit. So if you compare with the previous circuit, then in the previous circuit we don't have any resistor, right? So that is why we did not get any exponential behavior of the capacitor voltage or capacitor current. But here we have a finite resistor, that's why we got time constant as a finite, even though there is sudden change of voltage across the capacitor C1 and C2, but still it is reaching to some other steady state value exponentially. So that is what we got. And we can discuss one more circuit. So the circuit is given, and similarly the voltage 5 volt is applied for t greater than 0. So at t greater than 0, if you want to find time constant, then short circuit this voltage so that you have two capacitors are in series, are in parallel, because across these two terminals two capacitors are connected, and you have a resistor in parallel to them. So you will get time constant as C1 plus C2 times R. So there should be some exponential behavior in the circuit again, because time constant is finite, which means, yeah, and here the equivalent capacitance is C1 plus C2. So this is first order circuit. Since it is first order circuit, there will be exponential behavior, exponential voltage or current, VC, IC. Okay, so now let's start analyzing the circuit. At t is equal to 0 plus, short circuit the capacitors, then you have a resistor, so this we can neglect. So an impulse current is flowing through both the capacitors, which means there will be sudden change in the voltage across the capacitors. So this, if you want to find the voltage at t is equal to 0 plus, so this capacitor remains same, so you have very low impedance across some impedance, so equivalently it is a very low impedance, which is C2, and you have 5 volt. So VC1 is 5 C2 by C1 plus C2. Again you can assume C1 is equal to C2. So you will get 2.5 volt, and similarly VC2 you will get 2.5 volt, because C1 is equal to C2. So that is at t is equal to 0 plus. Now let's take at t tends to infinity, which is steady state. So at steady state, both the capacitor will be open circuited, assuming they are fully charged, and you have a finite resistor. So 5 volt, which means this is completely open circuited, right? So you have 0 amps of current flowing through a finite resistor. Similarly, you will get 0 volt of across these two terminals. So this is C2, this is C1. So VC2 is 0 volt. So this is equivalent to, you have C1 and you have C2. C2 is 0 volt, which means this is short circuited, right? So this is C1. So a complete input voltage is applied across the C1, right? So you will get VC1 is equal to 5 volt and VC2 is equal to 0. VC2 is 0 volt, VC1 is 5 volt. So these are the steady state voltages across the capacitors. So you can directly draw the waveforms. VC1 with respect to t, till t is equal to 0 it is 0, at t is equal to 1 it is going to 2.5 volt, and then for steady state it is going to 5 volt. So this we have seen in the previous problem, but with opposite capacitor, right? Because there is the resistor across C1, but now there is a resistor across C2. So you will get the same waveforms, but VC1 and VC2 are interchanged. So this is 2.5 volt and this is 5 volt. So for Vc2 it is going to 2.5 at t is equal to 0, and it is going back to 0 again. So initially it was 0, then it is changing immediately, then it starts discharging and it will go to 0. That is how these are behaving. So you can directly draw the current waveforms also. That is what the intention of the course. You have to draw the voltage and current waveforms of the capacitors and inductors intuitively. So the equations are secondary, but initially you have to draw this intuitively. So for IC1, since for t less than 0 it is 0, since the voltage is 0, and at t is equal to 0 there is some sudden change, right? So you will get an impulse function with amplitude of 2.5 C1. Since it is going from 0 to 2.5, the change is 2.5. So, and the capacitor is C1, you will get 2.5 times C1. And since it is charging exponentially, the current through the capacitor is positive. And since the voltage in steady state is constant, the capacitor current is going to 0. So there will be some initial current and this will go to 0. Yeah, and it will stay at 0. So similarly, IC2 is till t is equal to 0, it is 0, and at t is equal to 0 it is going to 0 to 2.5, right? So the change in voltage is 2.5. So you will get 2.5 times C2 impulse function at t is equal to 0. And the voltage across the capacitor C2 starts discharging. It means the current flowing through the capacitor C2 is coming out of the capacitor, which means the IC2 is negative. So it will go to some negative voltage and then exponentially it will go to 0. So this voltage should be minus 2.5 by tau, I think. So these two are interchanged, right? So you can directly write minus 2.5 C2 by tau. And if you want, you can write the expressions and you can derive and you will get the same, but C1 and C2 are interchanged. And this is 2.5 C2 by tau. So this should be 2.5 C1 by tau. So this is about this circuit. I have just placed a resistor from here to here compared to the previous problem. So yeah, and now let's discuss this circuit. So yeah, first find time constant. So since the voltage is there for t greater than 0, so find time constant for t greater than 0. I'm sorry. So the voltage should be short circuited and you have a resistor and a capacitor and a resistor, capacitor. So between these two terminals all the components are connected, these two resistors and two capacitors. So this you can represent as a resistor of R1 R2 by R1 plus R2 because these two are in parallel. Then a single capacitor of C1 plus C2. So which means it is a first order circuit with time constant of C1 plus C2 times R1 R2 by R1 plus R2. So this time constant is finite, which means there should be exponential behavior in the circuit. So finite time constant, and it is also a first order. So from these two we can say exponential behavior in the circuit, or exponential behavior of VC IC. So now we can find the voltages. So at t is equal to 0 plus $5 volt, then it is short circuited and this short circuited. So you can ignore R1 and R2 because those two are in parallel with the short circuited. So since these two are short circuited, a very high current is flowing. So if you want to find the voltages, then since both are low impedances and which is in parallel with some other impedance, so equivalently you can write it as a very low impedance and this is a very low impedance, ignoring R1 and R2. So this is C1, this is C2, and here also we can assume, suppose for this problem assume C1 is equal to C2, R1 is equal to R2. So maybe later we can discuss what happens if those two are not same and like R1 C1 is greater than R2 C2, or some combinations we can discuss. We can how to get that combinations and what will happen in the circuit, that we can discuss. So VC1 is 5/2, which is 2.5, since these two are same, and VC2 is also same, which is 2.5 volt. So this is at t is equal to 0 plus. Now what happens at t tends to infinity? Since both the capacitors are open circuited, you have these two resistors. So R1, R2 and 5 volt. So across this you have open circuited capacitor and this is open circuited capacitor C2. So VC1 is 5 times of R1 by R1 plus R2. So since R1 and R2 are equal, you will get 2.5, and VC2 is also 2.5 volt. So at t is equal to 0 you have 2.5, and also at t tends to infinity you have 2.5. But we are saying the time constant is finite, which means there should be some steady state voltage, and from some voltage to steady state voltage it should charge or discharge exponentially, right? So how does this circuit will work? Since at t is equal to 0 we have 2.5 and t tends to infinity we have 2.5. So will it stay at the same voltage or will it go to some other voltage and come back to 2.5? So that I think we can discuss in next class. Yeah, you can think about this circuit, what happens, will it stay at 2.5 or will it go to some other voltage and come back to 2.5? So just think about that circuit and we can discuss these waveforms in upcoming lecture. Yeah, thank you for watching this video. If you like this explanation, you can share to your friends, and if you have any doubts you can comment down, we will answer. Yeah. Thank you.